Let's go over the note that I had given yesterday after those formulae, that if you're converting one solid from one shape to another solid by melting and recasting, the volume remains same. And there were such questions which you did last year as well, where I think you can recall there was a question that there are 3 spheres, metal spheres of different radii, and all of them have been melted together and recast into a larger sphere. You have to find out what would be the radius of the larger sphere so formed. So what the concept used was that the volume of the 3 solids melted together and recast into the new one. Volume will be same. The volume of the 3 together will be equal to volume of the new one. So same thing will be used here when we are doing questions on volume where we have combination of solids. The only part which is tricky is when you are trying to find out what will be the surface area after you have combined a few solids. Before we start with the exercise, I would like to go over this example here. Like they have given this figure 13.4, as you can see. And if we wanted to find out the surface area for this solid over here, which is formed by a cylindrical portion in the middle, and there are 2 hemispheres on its ends. If you had to find out the total surface area, it will not be as simple कि हमारे पास 2 hemispheres हैं, हम उनका surface area निकाल लें और हम एक cylinder का surface area निकाल के तीनों को add कर दें. You need to identify that the solid so formed, जो फाइनल सॉलिड शेप बनेगी उसकी कौन कौन सी सरफेस है जिसका एरिया हम फाइंड करना चाहते हैं. So if you look at this final solid formed, you want to find out the area of this curved surface, which is for a cylindrical part, and the curved surface area of the hemispherical ends on the either ends. दोनों ends पे जो hemisphere लगा हुआ है. So the concept or the fact you want to remember, आपको क्या चीज ध्यान में रखनी है जब भी हम solids combine करेंगे, especially when you are trying to find out the total surface area, there is a possibility that one or more than one surface is disappeared. So they have shown they have shown this by indicating or highlighting the portion by shading it. So ये वाला जो portion है, the surface, circular base of the hemisphere, it will be joined to the circular base of the cylindrical portion. तो ये disappear हो जाएगा. ये surface exist नहीं करती हमारे final solid में, तो आपको इस surface का area निकालने की जरूरत नहीं है. सिमिलरली जो सेकेंड हेमिस्फेयर है उसका भी जो बेस है वो इस सिलेंडर के सर्कुलर पार्ट के साथ ज्वाइन हो जाएगा, तो ये दोनों सर्फेसेस भी क्या हो जाएंगी, डिसअपियर हो जाएंगी. आपको इन सर्फेसेस का एरिया नहीं निकालना. इवेंचुअली जो फाइनल सॉलिड बना है उसमें आपके पास सिर्फ कर्व्ड सर्फेसेस है, सिलेंड्रिकल पार्ट की कर्व्ड सरफेस है और हेमिस्फेयर्स की कर्व्ड सरफेस है. तो जो टोटल एरिया निकलेगा फाइनल सॉलिड का, इट विल बी गिवन बाय द कर्व्ड सरफेस एरिया ऑफ द 2 हेमिस्फेयर्स and the curved surface area of the cylinder. They have given another example here where they have joined a cone with a hemisphere. So this is surmounting a cone on a hemisphere, and the radius of the hemisphere matches with the radius of the cone's base. And in that case, this is the final solid formed. For this, if you have to find out the total surface area, it will be given by CSA of the conical part and the CSA of the hemisphere. So once you have identified and you know which is the right formula, you can just simply solve by applying that formula that you have. That's it. Is anyone also facing trouble with the screen not being visible?
No, ma'am.
No, ma'am.
No, ma'am.
Okay, if anyone's having trouble, please try to reconnect. There is one more case. I would like to show you this example over here, like this one. Example number 3, where there is a cone on the top and the bottom is a cylinder. It's not necessary that the sizes will match exactly. As for this case, the base radius of the conical part is bigger than the radius of the cylindrical part. So that is also a possibility. Please observe the question, identify के size match कर रहा है नहीं कर रहा, accordingly draw the figure and then see if you have to find out the surface area. इस केस में जब हम surface area निकालेंगे तो कैसे निकलेगा? एक तो कोन की कर्व्ड सरफेस आ जाएगी, एक सिलेंडर की कर्व सरफेस आ जाएगी, एक सिलेंडर का बेस होगा, एंड देन द पोर्शन विच इज राइट हेयर which will form a ring, they have shown here. आपको इसका भी एरिया निकालना है because the base of the conical part is exceeding the base of the cylindrical part, तो वो रिंग बनेगी, उसका भी एरिया आपको निकालना है. That will also be counted as one of the surfaces. So when the sizes don't match, there will be questions, there will be areas calculated this way. Let's start with the exercise. Question number 1. There are two cubes, each of volume 64 centimeter cube, joined end to end. You have to find out the surface area of the resulting cuboid. I would like you to draw a rough figure for this and then see how the question will be done. Since the cubes are of the same volume, cubes का volume same है, इसलिए उनकी dimensions भी same होंगी. First thing, if the cubes have equal volume, their dimensions will also be equal. So if we represent the edge of cube as x, the volume will be x cube and it's given to be 64. From here you can find out the value of x. And then if we had to show how the cubes are placed, this is one cube with edge equals to 4 centimeters. And then there is another cube placed right next to it of the same size. Now, what do you think about the new solid formed?
Cuboid.
Yes, it's a cuboid. And to find out the surface area of this cuboid, one more thing. Unless it's indicated, surface area would mean total surface area. So we have to find out the surface area of this cuboid. To find out the total surface area of a cuboid, the formula we use is twice LB plus BH plus HL. For this, you need the length, breadth, and height for the resulting solid. Can you identify what will be the dimensions for this cuboid? When you place two cubes of the same size next to each other, the way I have shown, what do you think will be the length of this figure? Just by looking at it.
8 centimeters.
That's correct. It will be 8 centimeters. यहाँ से यहाँ तक आपके पास डायमेंशन 4 है, उसके साथ एक और क्यूब प्लेस किया, उसकी भी मेजरमेंट 4 सेंटीमीटर्स है. So the total length will now be 8 centimeters. What do you think about the height of this solid from the base towards the top? Bhavna, could you please speak a bit louder?
It will remain same.
It will remain same. That's correct, Shaunak and Bhavna. The height will be 4 centimeters. And what do you think about the breadth, the width from the front towards the back?
It will be same.
It will be same. So once you have the length, breadth, and height, you can apply the formula. This is how you have to do the question. Whatever is given, identify how the figure will be formed. जो figure बनेगी उसमें जितने भी parameters include होने हैं. क्यूबॉइड के लिए हम लेंथ ब्रेथ हाइट लिखते हैं, वो आइडेंटिफाई अगर कर पाओगे बेटा तभी फॉर्मूला लगेगा. दैट्स द फर्स्ट थिंग यू वांट टू डू. सो अनलेस यू कैन आइडेंटिफाई कि जो आपके पास सॉलिड बन रहा है वो कौन सा है, उसकी डायमेंशंस क्या हैं, आप आगे काम नहीं कर सकते. सो प्लीज फोकस ऑन दिस. लेट्स राइट द आंसर साइड बाय साइड. Sahajan Taranum, that's correct. So all these line segments have the same length, 4 centimeters. This should help you now identify the length of the resulting solid, the breadth of the resulting solid, and the height of the resulting solid. You can write down what will be the length, breadth, and height for the cuboid so formed. The length will be 4 plus 4, 8 centimeters. Height and the breadth remains same. And now you can find out the total surface area. (64 and 16), 18 to 160. Done. Yes, Tarannum? Okay, go ahead if you're writing down.
Done, ma'am.
Question number 2, a vessel is in the form of a hemisphere, hollow hemisphere. So it's empty from the inside, just like a bowl. It's mounted by a hollow cylinder. The diameter of the hemisphere is 14 centimeters and the total height of the vessel is 13 centimeters. You have to find out the inner surface area of the vessel. Unless indicated, the base radius will be considered as same for the hemisphere and the cylindrical part. So there is a hemisphere and its diameter is 14 centimeters. So this is 14 centimeters across. It is surmounted or mounted by a hollow cylinder. So right on the top, there is a cylinder with the same base radius and it is placed over it this way. So there is a cylinder like this. The total height of this vessel is 13 centimeters. So from the top to the bottom, the height is 13 centimeters. You need to find out the surface area of the vessel. Please remember both the hemisphere and the cylinder are hollow. So cylindrical part का जो ऊपर से सर्कल आपको नजर आ रहा है, यहाँ पे सरफेस नहीं है because it's hollow, तो ये खाली होगा. तो जब हम इसका curved surface area, inner surface area निकालेंगे, it will include the curved surface area of the cylindrical part and the curved surface area of the hemispherical part. First of all, let me know if this makes sense to you. How are we going to find out the inner surface area for this vessel formed by a hemisphere and a cylinder? If this is clear, then we will see how or whether or not हमारे पास dimensions हैं या नहीं. Anyone who wants
Yes,
to?
ma'am.
Now to find out the curved surface area of hemisphere. हेमिस्फेयर के लिए तो सिर्फ एक ही चीज चाहिए, रेडियस. तो हेमिस्फेयर के लिए हमारे पास डायामीटर 14 है, वहां से हमारे पास रेडियस 7 आ गया. फाइन. यही रेडियस बन जाएगा फॉर द सिलेंडर ऑल्सो. तो सिलेंडर के लिए भी रेडियस हमारे पास 7 सेंटीमीटर हो गया. दूसरी चीज जो सिलेंडर के लिए चाहिए वो है हाइट. आपके पास हाइट यहाँ पे डायरेक्टली नहीं दी हुई, आपके पास टोटल हाइट ऑफ द वेसल है. यू नीड टू फाइंड आउट what will be the height of this cylindrical part. So for that, you can break down the total height into two parts, for the cylindrical section and for the hemispherical section. What do you think will be the height of the hemispherical part? It will be the radius of the hemisphere. So this is going to be 7 centimeters. From the center to the boundary. हेमिस्फेयर के सेंटर से अगर हम बाउंड्री तक मेजरमेंट करेंगे तो वो रेडियस बनेगा. इसलिए ये वाला पोर्शन जो लोअर पार्ट है इसकी हाइट 7 सेंटीमीटर होगी. नाउ कैन यू टेल मी व्हाट विल बी द हाइट ऑफ द सिलेंड्रिकल पार्ट? Check again.
6, ma'am.
6 centimeters. That's correct. It will be
Yes.
6 centimeters. Now, can you find out the curved surface area for both and then obtain the total? I guess, right? Anyone who
Yes,
has
ma'am.
doubt before we start writing? Okay, let's write down. So curved surface area of a cylinder is given by 2 pi RH, and for a hemisphere, it's 2 pi R square. And since the radius is same, I have used the same variable. अगर radius different होगा तो वह यहाँ पे variable change कर देना. Use capital R for one and small r for the other. So simplifying, I'm going to take these common 2 pi R. So 2 pi R, and I'll be left with H plus R. Is it correct?
Yes.
So
Yes, ma'am.
just trying to solve it quickly. Height and radius. The height for the cylinder is 6. The radius is 7. And this becomes 44 multiplied by 13. And now you can obtain your answer. Those who have done this can try the next one. Draw the figure by the time we are waiting for the students to write this down. Okay, shall we do the next question now?
Yes, ma'am.
Ma'am.
A toy is in the form of a cone of radius 3.5 centimeters and it's mounted by a hemisphere. So now you have a conical shape mounted by a hemisphere. It will look like a top actually. And you have to find out the surface area of the toy. You have been given the total height of the toy, somewhat similar to question number 2. So draw a figure quickly, and since it's not indicated that the radius of any of the two shapes is larger, we will be considering that they have the same radius. So if we had to draw a rough figure, we need to draw a cone. It's mounted on a hemisphere, so it will be opposite. So the cone is on top and there is a hemisphere on the bottom. So this is the shape that you have. The base radius for the conical part is 3.5 centimeters. And we are considering that, yeah, it's given actually. I'm sorry, I didn't notice that the hemisphere is also of the same radius. So the radius of the hemisphere is also 3.5 centimeters. The total height is 15.5. You have to find out the total surface area of the toy. So what will you do to find out the total surface area? Anyone?
Area of hemisphere plus area of cone.
Of course, but which area? We have two types of areas, total surface and the
surface.
curved.
Of
That's
surface
correct.
area.
That's correct. We will be calculating the curved surface area of the two shapes and adding it together. So we need curved surface area of the cone and we need the curved surface area of the hemisphere. For the hemisphere, the curved surface area is given by 2 pi r square. So this will not be a problem because r हमारे पास already है. For the cone, do you remember what the formula is for the cone? The curved surface area.
Ma'am, pi RL.
Pi r L. So we have the radius for the cone, but we do not have L, the slant height. We need the slant height for the cone. For that, we will need to use the Pythagoras theorem, L square plus R square, sorry, L square equals to R square plus H square. First of all, let's identify what is the height of this conical part.
12 centimeter.
12 centimeters. The total height is 15.5 and the height of the hemispherical part is 3.5. So 15.5 minus 3.5 will give you the height of the conical part. Now you can find out the slant height for the conical part before you calculate the curved surface area. Is that clear?
Yes, ma'am.
Yes, ma'am.
Let's write down. Now I'm writing it in short. If you want, you can write it this way directly, that there is a hemispherical part, उसके parameters कौन कौन से हैं, और हमारे पास एक conical section है, उसके लिए कौन कौन से parameters हैं. Radius is given to us. Height we have observed, total height minus the height of the lower part, and then we need the slant height. This will be given by the square root of h square plus r square. Calculate and tell me what the answer is. (25 by 2). All right, so that will be 12.5. And once again, since the radius of hemisphere and the cone are same, I have represented them with the same variable. Like I'm reminding you again and again, जहाँ पे ये change होंगे, हम different variables लेंगे. And because of this, I can do the simplification easily. I'm going to take pi r common, and I'm going to keep these like using distributive property. I is not indicated. Radius is 3.5. I'm writing it as 35 by 10, twice the radius, plus the slant height, which is 12.5. Find out your answer. Okay, so Meet has done it. The answer is 214.5 centimeter square. Be careful about the units as well. So this actually is 11 into 19.5, and it gives you 214.5 centimeter square. आप अलग अलग निकाल के भी ऐड कर सकते हो, पर थोड़ा काम ज्यादा हो जाएगा. And once you write like this, it's easier taking things common if there are. If anyone's writing.
No, ma'am.
Question number 4 and question number 5 are a little trickier compared to the ones we just did. We have been given that there is a cubical block of side 7 centimeters. It's surmounted by a hemisphere. अब ये दोनों objects जो हैं, they are different in shape as such because cube is a polyhedron, whereas hemisphere is a solid with curved surface. तो हम radius same नहीं बोल सकते because cube का तो radius ही नहीं होता. So roughly drawing, let's first of all draw a cube, and we want to draw a hemisphere right on its top. They are saying that the hemisphere should be of the greatest diameter possible. So जितना बड़ा hemisphere आप यहाँ बना सकते हो, उतना बड़ा बनाना है. The largest hemisphere that is possible will touch the sides of the square on top. इस तरह से बनेगा. Is that correct? The base of the hemisphere, largest, yes, it will touch the edges on the top. This is how the hemisphere will be if it is of the largest diameter. The first thing they're asking is what is the diameter that it can have? The largest diameter, it will be the distance from one edge to the other edge. So what do you think will this be? This distance will match the length of the edge. Only then the hemisphere will have the greatest diameter possible. Does that make sense?
Yes, ma'am.
Once you have the diameter of the hemisphere, you will get the radius of the hemisphere. For the cube, we only need one thing, which is given, side of the cube. Further, they are saying find the surface area of the solid. Now for this solid, find out the surface area. Since it's not indicated, we will be calculating the total surface area. Take a moment here and think what will be the surface area of this solid formed by mounting a hemisphere on top of a cube. Now there are multiple ways. I will be using the shortest way possible. So I'm going to write down the total surface area of the cube. पूरे क्यूब की surface area निकाल लो minus the base area of hemisphere because वो disappear हो जाएगा. This portion is now hidden, so ये exclude करना है plus the curved surface area of hemisphere. Do you follow?
Yes, ma'am.
Yes, ma'am.
Surface area of the cubical block plus CSA of hemisphere minus area of the base of the hemisphere. That's correct, Shreyas. So this is what we will be doing. So first of all, we want to answer what will be the greatest diameter possible for the hemisphere. It will be equal to the edge of the cube. So you can draw the rough figure quickly and then write down the answer. This is the greatest diameter. The things to be added can be listed first. Total surface area of the cube will be 6a square. The base area of the hemisphere will be pi r square. Then the curved surface area will be 2 pi r square. From here, you have 6a square plus pi r square. And now you can substitute the values. So 6 times 7 squared plus 22 by 7 times 7 by 2 squared. Simplify your answer. So this is the answer, 332.5 centimeters square. Anyone who's writing?
No, ma'am. No, ma'am.
No, ma'am.
Question number 5th. A hemispherical depression is cut out from one face of a cubical wooden block such that the diameter L, now the diameter is represented by L for the hemisphere, it's equal to the edge of the cube. So diameter will be taken equal to L and the edge of the cube will also be taken equal to L. Numerical value nahi di, variable ki terms mein answer aayega aapka. A depression is cut out. In the previous question, a hemisphere was mounted on the cube. Here, a depression has been cut out. Think of it like scooping out ice cream from ice cream tub. A depression is formed. Scoop jab aap nikalte ho ice cream ka. So a depression is formed and it's usually a hemispherical figure. So that kind of shape is formed. After that, you want to find out the area of the solid. Try drawing the figure in rough. So you will have a cube first of all, and then you want to draw a hemispherical depression. So rather than showing the hemisphere on top, now you have to show the hemisphere inside the cube. So it will be like this. So I'm going to just draw this. So this is inside the cube now. And the diameter is equal to the edge. So the base of the hemisphere will touch the edges. Draw accordingly, but it will not touch the other end because the radius will be halfway for the cube. I hope no one eats ice cream with their hands from the tub.
No, no, ma'am.
Yeah. Remember, we don't have numerical values. The answer will be in terms of L here, the diameter given to us.
Ma'am, less than 1 minute is left.
I know. Let's just see how much we can write down.